Bismillah ar-Rahman ar-Rahim. Today we are going to start a new book, Introduction to Management Science, and the first chapter is just introduction to what management science is. So we are going to discuss some basics of what scientific approach is and we are going to discuss a break-even model in it and decision support systems which help in making the decisions. So these are the topics we are going to cover: the management science approach to problem solving, management science and business analytics, model building, in which we will talk about break-even analysis, computer solution, management science modeling techniques, business usage of management science techniques, and management science models in decision support systems. The management science approach. Management science is a scientific approach to solving management problems. Scientific is also sometimes said as logical, using mathematics or probability and statistics in decision making. It becomes a management science. Management science is used in a variety of organizations to solve many different types of problems. The types of problems could be production related, inventory related, minimizing the costs or maximizing the profits, etc. It encompasses a logical mathematical approach to problem solving. So again, the same thing: logical, scientific, mathematics, all are same thing. Management science, also known as operations research, it has different names. Operations research is there, as you might be knowing that in industrial engineering we have two subjects, operation research 1 and operation research 2. Basically they are management science courses. Quantitative methods, business analytics. Business analytics is nowadays also very much in use, kind of a buzzword, basically using big data and mathematical models to make decisions. This management science model involves a philosophy of problem solving in a logical manner. Here we have the process of management science process is there. We observe, there is an observation that there may be a problem. We gather the data related to that and we define the problems. Define the problems properly, its boundaries, its interaction with other departments, the effects, etc. The problem is properly defined, and then a model is constructed. After constructing the model, the solution is found, and then it is implemented. Now, after implementation, it is possible that you would like to go back and see the solution again. Maybe you want to do some sensitivity analysis. What if this happens? What if that happens? And you want to see the effects on that. Or after implementation, you found that the model need to be fine-tuned. It is not working properly. It is not as giving the right results. For example, if it is a forecasting model, sales forecast, and when it is solved and implemented, it found that the sales forecasts were wrong, were quite far from the normal error, forecasting error. So you might have to go back and look at the model again, model construction. Or after implementation, it is possible that you found that you didn't realize that some other departments have to be affected with the implementation. So the problem was not properly defined. So you go back to the problem definition. So these is the feedback loops are there. Again, these steps are repeated here. I will not go through this. You can read it yourself. Okay, let's look at the example of model construction. Let's say we have information and data is there. A business firm makes and sells a steel product. Product cost $5 to produce. Product sells for $20 and it requires 4 pounds of steel to make. And firm has 100 pounds of steel. So this data or observation is there. So this is the first step we talked about in the process. Then we define the problem. The problem is determine the number of units to produce to make the most profit, giving the limited number of steel available. So then the third step is the model construction, and here we define the variables. Let's say X is equal to number of units to produce. This is a decision variable, and Z is the total profit we want to maximize that. And our model is that Z is equal to 20X minus 5X. 20X is our revenue would be there. 20 is the sales price, multiply with the number of units you produce, or total sales will be there. Minus 5 is the cost of production, multiply by the number of units you produce, X. And then we have a constraint here. 4X is equal to 100 pounds of steel. So the maximum we can produce is about 25 pounds, number of units. The fixed numbers here in this model, 25, 4 and 104, all these are known as parameters because they are fixed and they do not change while we are solving the model. And X is the variable which we is the decision variable which we need to find out. So this problem is again written in a formal way. Maximize Z is equal to 20X minus 5X subject to this constraint 4X is equal to 100. Now, after constructing the model, we solve the model, and this is the solution. We find that maximum number of units we can produce is 25 using this constraint, and then you just substitute this X in the objective function. Z is equal to 20X minus 5X. Just put 25 there as X is equal to 25, and you find 375, which means that the maximum profit you can get is 375 and the maximum number of units you can produce is 25 units. This was a very simple example of model construction. Management science and business analytics. Business analytics uses large amount of data with management science techniques to help managers make decisions. So as I said earlier, that business analytics is the nowadays common buzzword. It is basically the same as management science techniques, but it uses large amount of data together with management science techniques or models, which helps the managers to make decisions. It brings together information technology, statistics, management science, and mathematical modeling. And of course, it's using big data. Nowadays, big data is generated every transaction we make, when we use mobile, our phone, when we make any online shopping, etc. Big data is generated, and the data generated is in large quantities, and trying to make sense of this data and using mathematical model is to make decisions is business analytics. Now we will see a little bigger example of break-even analysis model building. Break-even analysis used to determine the number of units of a product to sell or produce that will equate total revenue with total cost, and the volume or number of units at which total revenue equals total cost is called the break-even point, which means that the profit becomes equal to 0 at break-even point. Now we will use some notations here. Fixed cost. Fixed cost is that remain constant regardless of the number of units produced. We have talked about fixed cost also when we were talking in engineering economics lecture. Variable cost is the cost which varies with the number of units we produce, and volume, the number of units produced or sold, is volume, and the total variable cost is function of volume and unit variable cost. So number of units multiplied by the number of units sold multiplied by the variable cost will give us the total variable cost. So the total cost is then the summation of fixed cost and variable cost, and the profit is equal to revenue minus expenses, and revenue or sales would be equal to unit price, which is P, multiplied by the volume or number of units sold, is the total revenue minus the total cost, and the total cost is CF minus VCV, total variable cost. Now to compute the break-even point, we said that the profit should become equal to 0. So when we make it equal to 0, then we can just manipulate this equation and find the break-even point. The break-even point gives us the volume, the number of units to produce, is equal to fixed cost minus the selling price, fixed cost divided by selling price minus the variable cost per unit. Again, number of units to produce is equal to fixed cost divided by the selling price per unit minus the variable cost per unit. Let's see an example. A company is Western clothing company, which is making pairs of jeans. Its fixed cost is $10,000. Variable cost is $8 per pair, and price is equal to, selling price is equal to $23 per pair. The break-even point is then fixed cost divided by the selling price minus the variable cost per unit. So we got 10,000 divided by 23 minus 8 equal to 666.7 pairs of jeans. Here is, if we plot that against volume, if we plot the number of units and the revenue and cost and profit on y-axis and volume on the x-axis, we can see that the fixed cost is fixed at 10,000. Okay, it is fixed at 10,000, and as we start producing number of units more, the total cost start increasing because of the variable cost is increasing according to the number of units to produce. On the other hand, our profit will start, the revenue will start from the zero, and it will keep increasing as we produce number of units, and finally we reach when the two curves meet each other, the total revenue and the total cost meet. That is when they are equal, then this is the break-even point. Beyond break-even point, we will get profit, and below this break-even point, it is still losses there. We can do sensitivity analysis. Here we have increased the selling price. When we increase the selling price, it means the difference between selling price and the variable cost become more, and the break-even point is even earlier, so that this is the new break-even point. We can also change the variable cost, and we can see that by increasing the variable cost, our new break-even point has shifted to the right side, which means we have to produce more number of units to break even. We can also do sensitivity analysis by looking at what if we change the fixed cost from 10,000 to 15,000, and again the break-even point moves towards the right side, which means that we have to produce more number of units to break even. We can use Excel. So this is just an example giving that in Excel we can use all the features. It's a very powerful spreadsheet tool which can be used to solve problems. Also, QM Windows, this book has a website from where you can download the Excel QM. Excel QM you can download, and it has modules. It has it gives by chapters also. This book has the chapters, and according to the chapters you can search for the model, or alphabetical also way we can search the break-even analysis there, right? So it's chapter 1, we can either from chapter 1 or alphabetical order we can check at break-even at B. You can see the break-even analysis, and it creates a nice graph also. It's very easy to use. I recommend that you use Excel QM to learn your concepts more. It's a very helpful tool. Similarly, another helpful tool is QM for Windows. It is not Excel QM, it is QM for Windows. Okay, here it is, QM for Windows. This program is also very user-friendly. It's very interesting, and I also recommend that you can download this freely from the book website. It has all the different modules. If you just click on that, you can see many different modules. You can solve, for example, linear programming, forecasting models are there, inventory models are there, transportation models are there, etc. And it can also draw graphs as well. So this is QM for Windows, showing the graph. Now this book has many because this is an introductory chapter, it is telling what this book has inside in it, and there are many different chapters. Actually, we are not going because this course is not on management science only. It's just giving some flavor of management science. So we will only learn 2 or 3 chapters in it, and these are the chapters we are going to cover: linear programming models, graphical analysis, and sensitivity analysis. And we are going to learn about decision analysis. That's it. We are not going to cover anything else in it in this semester. This is just giving what in this chapters are there in this book. So some application area of management science techniques is in project planning and scheduling. It's PERT CPM is, for example, is discussed there. Capital budgeting, inventory analysis, production planning, scheduling, etc. These are the different areas in which these management science models discussed in this book are can be used. Another thing is interfaces application journal is there, which is published by Institute for Operation Research and Management Science. This is another good source to look at. Management science models in decision support system. Now, a decision support system is a computer-based system that helps decision makers address complex problems that cut across different parts of an organization and operations. We have discussed management information system. Now here we are talking about decision support system. What is the difference? The difference of is that management information system is for structured problems decision making, but for complex problems, unstructured problems, decision support systems are there which help the decision maker to interact, to ask what if questions, and solve them using the management science techniques, and then make the decision. The common features of decision support systems are interactive. It is interactive. The user interface is there, uses databases and management science models, and addresses what if questions or performs sensitivity analysis. What if questions or sensitivity analysis is the same way or same thing. The examples include ERP, enterprise resource planning, OLAP, online analytical processing. These are the different softwares. Just to give you idea about ERP, enterprise resource planning system, it's a large scale DSS, decision support system, that include a forecasting model to analyze sales data and help determine future product demand, an inventory model to determine how much inventory to keep on hand, a linear programming model to determine how much material to order and product to produce and when to produce it. It may include also a transportation model to determine the most effective method of distributing a product to customers, and a network flow model to determine the best delivery routes. All these different management science models and the necessary data to support them can be linked in a single enterprise decision support system, DSS, that can provide many decisions to many different decision makers. Here we are showing the decision support system. There's a decision maker who is interacting interfaces there, and there are management science models are there, and there is a huge database making use of that, and big data we talked about, and then internet or e-business is there. Internet in e-business applications, company can link to other business units around the world through computer systems called intranets, with other companies through systems called extranets, and over the internet. For example, electronic data interchange and point of sale data through barcodes can provide companies with instantaneous record of business transactions and sales at retail stores that are immediately entered into a company's DSS to update inventory and production scheduling using management science models. So uh, this is how the structure looked like of decision support system. Thank you very much.